Alright, in this video, I'm gonna go through 7-segment displays. A 7-segment display is a component that has 8 LEDs. Um, it has 8 LEDs, and they are put in these segments like this, and then there's one dot here. The reason why it's called 7-segment display instead of 8-segment display, I suppose it's because 7 segments are used to display a number, and then the 8th LED is actually used for a decimal point, because 1, 2, 3, 4, 5, 6, 7, 8, yeah. So I suppose that's why they call it 7-segment display. But anyway, I digress. So this component has 8 LEDs, and it has these pins. And these pins allow us to power each individual LED as we see fit. And yeah, that's pretty much it. That is pretty much 7-segment displays. But there are two different types of displays that you need to know, and they operate differently. And that is the common anode 7-segment display and the common cathode 7-segment display. Before I move on, the display has these pins, right? These G, F, A, B, E, D, C, and DP, right? They are inputs that correspond to the specific segment. For example, this pin here corresponds to the A pin. So basically, when you input what you need to input, what you need to input differs with the different type, but I'll just call it what you need to input for now. When you input what you need to input, then A will turn on. For B, if you input at B, that thing, then B will turn on. So that's what the pins do. What is the common pin? We will go through that now. Okay. So the only thing that differs between the common anode and common cathode display is what the common pin is, and I suppose the configuration of the LED lah. But I'll get into that later. So in the common anode 7-segment display, the common pin is actually VCC, or like 5 volts or higher. And for the cathode one, the common pin is ground, or 0 volts. Why is it like this? Because of the way the LEDs are arranged, or the way power is fed into the LEDs. For the common anode, common anode 7-segment display, how it works is VCC actually goes into the LEDs, and then the output, right, which would be the cathode of the LED, will go to A, and then A, in order to turn on A, because the circuit is not closed, you have to ground A. You have to put 0 volts at A, which would turn A on. So I can show that with an example here, which demonstrates the idea better. So this is segment A, and it is connected to VCC, and this is pin A. So basically, in order to turn this on, we will need to ground A. So that's our input for A, is 0 volts. For the common cathode one, the common pin is ground, and A actually supplies the voltage to the segment A, which we can see here as well. So A needs to be at VCC, or high voltage, which will go into the LED, and then the LED will ground itself at the common pin. So that's how it works. You can better see it here, like in this diagram. We can see how the LEDs are connected. Like in the common cathode one, which is this one, we can see that A needs to be at high voltage to power the LED, then it grounds itself at the common pin. Or like in F, right, the F needs to be at high voltage to power this LED, and then it grounds itself at this common ground pin. And for the anode, the common anode 7-segment display, we can see all of the cathodes of the LEDs, they are grounding at the pins, and VCC is connected to all the anodes of the LEDs. So in order to turn this LED on, like A for example, we have to ground pin A. Or to turn on B, we'll need to ground pin B. So it's pretty simple lah, that's it. But this difference you need to know lah. So that is 7-segment displays. This is a short video because it's actually quite simple. So yeah, alright. Thank you for watching.